All right, guys, so for today's lessons, all of the equations we've solved up into this point has had one solution, but today we're going to look at problems that have either no solution or infinitely many solutions or one solution like we have been solving. All right, so the first thing that we're going to do on number one is we're going to distribute that 7 to everything in the parentheses. So 7 times 2, my pen doesn't like that loop-de-loop. 7 times 2 is 14, and 7 times 5v is 35v. And then we're going to bring down what's on the right side of the equal sign. So yesterday's lesson was having variables on both sides of the equal sign. So we want to get our variables together. So I'm going to move the smallest v, which is 3v. So to get rid of a positive 3v, I'm going to subtract 3v from both sides. Bring down that equal sign. 3v minus 3v is 0. I'm going to bring down my 14. I'm going to bring down 35 minus 3 is positive 32. Bring down my equal sign and bring down 14. I want v by itself on one side of the equal sign. So I'm going to get rid of this positive 14 by subtracting 14. And I have 32v is equal to 0. And then the opposite of multiplying by 32, I'm going to divide both sides by 32. So my 32 will cancel, and 0 divided by 32, if I put that in my calculator, I see that the answer is 0. Well, that's okay. You can get v or x equals 0. So there's one solution, and that solution is v equals 0. So how would I check my answer? Well, after I distribute it up here, I could check my answer. I'd say 35 times 0 is 0. 0 plus 14 is 14. So I get 14 on the left side equals 3 times 0 right here. 3 times 0 is 0, and 0 plus 14 is 14. So is this true? Does 14 equals 14? Yes, it does, which makes me know that my answer is correct. All right, let's go on to number 2. Number 2, we're going to distribute that -7 on the right side of the equal sign. So -7 times p is -7p. -7 times -5 is positive 35. So I have two variables on both sides of the equal sign. So to get rid of this -7p, I'm going to add 7p to both sides. Well, what happens? -7p plus 7p is 0, so that's gone. It happens on this side exactly the same as it did on the first side. And then I bring down my 35. All right, so we'll look at this. It says that 36 is equal to 35. Is that true? Does 36 equal 35? No, it's not true. No. So that means there is no solution. So when you get a statement that is not true like this one, that means there's no solution. In other words, there's no value I could give to those variables that would ever make this side of the equal sign equal the right side of the equal sign. All right, number 3, I'm going to distribute that -5. So first of all, I hope you guys printed this and you're doing this with me. And then when you feel comfortable, you stop the video and you do these on your own. All right, you got to learn by doing, not by watching, okay? Excuse me. Okay, -5 times -2 is positive 10. -5 times -8m is positive 40m equals 10 plus 5m. All right, we have m's on both sides. I'm going to get rid of my smallest one. I'm going to subtract 5m from both sides. So what do I bring down? Well, I bring down 10. This is equal to positive 35m. Right side, I bring down my 10, and this canceled. I want this m by itself, so I'm going to get rid of this positive 10 by subtracting 10 from both sides. So I end up with 35m is equal to 0. And then I still get to divide both sides by 35. So my math problem is m equals 0 divided by 35, which is a real number. That equals 0, which is true. So I get one solution. So on your work today, when it is one solution, you have to write what that solution is. So this one equals 0. So if I plugged in after I distributed on this line, if I plugged in a 0 to both of these variables, I would find out that I would have 10 is equal to 10, which is true, which makes me know my answer is correct. All right, number 4, I'm going to distribute that -2. So -2 times v is -2v. -2 times -2 is +4. Bring down my equal sign. I have -3 minus 2v. I'm going to get rid of this -2v by adding 2v to both sides. What happens, it makes my variables on both sides cancel. Do you see that? So I bring down 4 and I bring down -3. And I get a statement here that says 4 is equal to -3. Do they have the same value? No, of course not. No. So that means there's no solution. No solution. All right, I'm going to erase this stuff so we can see a little better. All right, number 5, I'm going to distribute that 7. So I have 30 plus 6p equals 7p plus 30. Wait, what am I saying? For 1 minute, I forgot what 7 and 6 multiplied together gives me. It's 42 minus 5. Okay, so what do I have? I have p's on both sides of the equal signs. I'm going to get rid of the 6p. Oh, and I could add this too. So let's go ahead and add this. This is plus 37, right? 42 minus 5. All right, so what do we have? We're going to bring down. This is gone. We have 30 equals. We have 7p minus 6p is 1p, and 1 times p is just p plus 37. I want to get rid of plus 37. I'm going to subtract 37 from both sides. So p is equal to 30 minus 37 is -7. Can I get that? Yes, I can. So I have one solution, and that solution is p equals -7, which means if I plug in a -7 into these spots for p, I would find that this side of the equal sign is the same as the right side of the equal sign. Okay. All right, we're going to distribute. So I'm going to bring down 8x plus 38 equals positive 18 plus 12x. So I want to get rid of this 8x by subtracting 8x from both sides. So I have 38 equals 18 plus 4x. I'm going to subtract 18 from both sides. So I end up with 20 equals 4x. When I divide both sides by 4, I get x is equal to 5. So I have one solution, and that solution is x equals 5. All right, let's look at this one. So we're going to distribute that -4. -4 times v is -4v. -4 times 3 is -12 equals -12 minus 4v. All right, if you pause a second, even though this is written in the opposite order, I could bring that -4v to the front and send that -12 to the back, couldn't I? And do you notice that these match perfectly? This is equal to this. Do you agree with that? That means if I put in any variable, any value for that variable, I'm going to always get the same answer on both sides. If I didn't notice that and I said, okay, well, I have v's on both sides, so I'm going to get rid of this -v by adding 4v. Well, what would happen is my variables would both cancel and I would end up with -12 equals -12. Well, is that true? Yes, it's true. That means I have an infinite number of solutions or infinitely many solutions. That's what the title of this paper says at the top, doesn't it? Doesn't it say infinite many? Should say infinitely many, but whatever. All right, so that's an example of one that has an infinite number of solutions. When they match exactly, or when you eliminate one of the variables, you have a true statement. The other ones that had no solution were false statements. All right, so let's see what happens here. -3 times v is -3v. Minus 12 equals 2v minus 37. I'm going to move this -v, so I'm going to add 3v to both sides. So this is gone. I bring down my -12, my equal sign. 2v plus 3v is 5v. And then how do I get rid of minus 37? Since my v's over here, I want to move minus 37, so I'm going to add 37. And when I do, I get, let me just be lazy. I'm going to do -12 plus 37 is 25. So 25 is equal to 5v. What's the opposite of multiplying by 5? I'm going to divide by 5. So v equals 5. So guess what? I have one solution. V equals 5. Okay, we're almost done, guys. So I'm going to bring down 3 plus 5n. Equals 5 times n is 5n. 5 times 2 is plus 10 minus 7. Well, 10 minus 7 is 3. So 3 plus 5n equals, oh, I forgot my n. 5n plus 3. Well, guess what? Those are exactly the same. If I tried to get rid of 5m by subtracting, I would end up with 3 equals 3. That's true. So I have an infinitely many solutions, infinitely many solutions. If you come up with a true statement, that's the answer, infinitely many. All right, and then let's get rid of all that. Next, oh, no, I didn't mean to do that. All right, so we're going to distribute. So 4 times k is 4k. 4 times -8 is -32 is equal to -32 plus 4k. Are these equal? They absolutely are equal. I could stop there and say infinitely many, or I could say, well, let me get my k's together, which is really going to just mean that I eliminate them and I end up with a true statement. That is true, yes. So once again, infinitely many solutions. Okay, so you guys try those problems, the ones that I've given you to print, and I want you to send me your answers. If you need me while you're working on it, let me know and I will help you. Have a good day, guys.